And what's really great is that because we added in closing and opening states, we can actually hit F multiple times, and we can reverse the direction of the animation at any point, even if it is currently opening or closing. And it's going to look smooth and play back properly, no matter at what point I actually interact with the door. Hello everybody, Chris here, and in this video I want to show you guys how we can take this door, which opens instantaneously when we press the F interact key, as we set up in the last video, and take it and turn it into a door that opens through a smooth animation. So when we press the F key, it'll animate over, let's say, 1 second to get to its open state, and likewise it can reverse and close with the same amount of time. So for this door animation, there's going to be 4 theoretical states that the door can be in. It can either be open, it can be closed, or it can be opening or closing. So in order to demonstrate those different states and code very easily, we can create a list of enumeration values. So you can see here I've created one called eDoorState, but I'll go ahead and create one again just to show you how it's done. So if you right-click in your content browser, you can go to Blueprints and find Enumeration, and you can say eDoorState Tutorials, or something like that. So the E represents that this is an enumeration asset, and when you double-click it, you can open up and edit the enumerators. So like I said before, there's going to be 4 enumerator values. So if we hit New, we can define this, and I'll just hit New 4 times, so we have 4 different display names. So we need let's say closed first, because that'll probably be the default for a door. And then we also have open, and then you can type in, let's say, closing, and then opening. So I'll go ahead and save that here, and that's all we need to do with this. So when we go to create the blueprint now, we'll be able to create a variable from this enumeration list, and the variable will be able to have these 4 possible values, which makes it really easy to do a switch statement, which means that depending on which value this is, it'll do something different in the code. So let's close that and open up the blueprint for the door. So let's maximize this, and you can see that in the previous video, I set up an event interaction. And so how this works is that there is an interface class, an interactable blueprint interface, that we can attach to any object which is going to receive this event, and that when this event is triggered, in this case by the character going up to the door and pressing F, seeing if there's a collision with an interactable object, such as this blueprint door, then it's going to trigger this event interaction, and it's going to go into the branch, is open. If it's not open, then it opens the door, and if it's already open, then it closes the door. If it is closed, then it opens the door. But in the current code, it does that instantaneously by immediately setting a new rotation value. But by using an animation node, we can have that value change over a certain amount of time. So if you already have this code, we no longer need it for the most part. I'm just going to take all of this, move it down here. The only parts we're really going to want is this little bit about setting the relative rotation of the door. So I'll keep the door reference, the closed door rotation, which is a vector value with x, y, and z. And I will Control-C copy these up here. So at some point during whenever the animation updates, we'll feed into here what the new position should be. So we're going to need a new variable that holds and references the state at which the door is in for its animation. So hit plus on new variable, and we're going to select from this drop-down list. I'm going to type in tutorial to find the eDoorState tutorials enumeration values. So that's what we set up in that enumeration file. And now with that value, we can pull this out here and get the value of it. So to make it clear what this variable is, I will change the name of it, and we can call it state or door state, something like that. And whenever the interaction event is pressed, we're going to want to get what state the door is in to determine what we should actually do with the door at that point in time. So if it's closed, we want to start opening it. If it's open, we want to start closing it. But also, if it's in the process of being closed or opening, we want to reverse the direction and head towards the opposite state. So if it's opening, we want to actually make it closing and reverse the direction. So we can do all of that pretty easily with an animation node. So let's find out what state this variable is in using a switch. So search for switch when you drag off the pen. And you can see that there's going to be 4 possibilities: closed, open, closing, and opening. And we will use all of these. So we're going to need to feed in the execution pin to this switch, and that will allow us to figure out what to do at that point. So all of these nodes are going to feed into an animation node. We can add one by right-clicking on the event graph and searching animation. So we can create an animation timeline node now by right-clicking on the event graph and searching for timeline. And we want add timeline here at the bottom. So you can see the timeline node is a little complicated. It has a lot of different possibilities in here. But using a switch statement on an enumerator like this makes it quite easy to see what's really going to be going on here. But before we link up these pins, let's double click on the timeline so that we can set what values are going to occur as time changes. So we double click on that and we're going to want a float value. So this float track is going to contain the value of how open the door is from 0 to 1, 1 meaning 100% open. And over a certain duration, we'll make it probably 1 second here. It's going to increase that value up to 1 with a simple graph. So I'm going to hit add float track, and you can see that we get a standard XY graph where X over here is the time, and then Y is going to be the value of the float, which is obviously going to change across time as we go from 0 to 1 second. Now you might notice that the graph by default is 5 seconds. We don't want the animation to take 5 seconds. We actually want it to complete at 1 second, or however fast you want the door to open. So change the length of the timeline up here from 5 to 1, and you should see the dark gray area move way over here to the left. The next thing we need to do is add in a couple of keyframe points for the values. So the first value is going to be at 0 seconds, and that is going to be a value of 0. So right click and add in a keyframe point there, and make sure that the value for time is set to 0, and that the value for the float is also 0. Next, you can right-click over on the graph, set a new keyframe point, and we want this to be 1 second and 1.0 in its value, so it's much easier to manually change the values when it needs to be a precise number like this. So right-click, add the keyframe point in, left-click to select it, and then type in 1.0 for the time and 1.0 for the value. That way, it is precisely the number we need. Now, to make the door open more smoothly and close more smoothly, we're going to want to add a auto curve to these two keyframes so that it starts a little slow and ends a little slow, but in the middle, the animation speeds up a little bit, and that'll make it look more smooth. So with these two keyframes selected, you can right-click and then choose auto for the key interpolation. So when we do that, you see that it gets these Bezier handle curves, which you could play around with to adjust how the animation looks, but we're just going to use the auto. So you can see that when we have these auto curves, that the speed at which the values changes at the end and start of the animation slows down a little bit, and generally that'll look better for this kind of simple animation. So let's go back over to the event graph, and then we might actually want to rename this timeline node, so you can select it and say door animation or something like that. Just make it a little bit more clear. Okay, so now we need to figure out what to do depending on what state the door is currently in whenever the interaction button is pressed. So if it is completely closed, we want to open it. Playing to the end would be the opening animation. So if it is closed, we want to play from start. So that means it's going to go to the time 0 point in that float graph, and it's going to start playing from there. So the full animation of playing to the end. And if it's open, we want to do reverse from end because we assume that it's completely open and we want to go backwards, so closing the door. Now, if it is currently closing and we press the event button, we actually want to reverse the direction. So we are going to want to make it open because it's already starting to close. So closing is the reverse. So we actually want to link this up to play in order to make it go forwards towards the opening direction. And likewise, with opening, we want it to go in actual reverse for the graph to make it close, so going towards that float value of 0. And when we've done that, that's all the linking up we need to do here. And it should be very clear what each of these enumeration values are going to execute and do with this timeline graph. So in that way, having this switch here is a lot more clear than having, let's say, Boolean branches branch off of each other. You might end up with like 3 separate branches linking into that, and that could be a little bit confusing, but this should be really, really clear. Okay, so now whenever the timeline is updating, which would occur on every frame, we're going to want to set the rotation of the door to its new value. And that's going to be based on the percentage that the door is open, which is the float value we're getting from the door animation. You can see that we didn't rename this track though, so it's not exactly clear what that float does. So I'm going to double click it, open it up, and rename this track. And we can call this something like door opening value. Maybe you can think of a better name, but I guess that'll do for now. And we're going to want to multiply this by the open door rotation. So the open door rotation, you can see here, I set this before from the original code, is a vector of 0 on the x and y, and then 90 for the degrees rotation of the open door. And this is a variable that's instance editable, so you can set how open a door should be if it is actually fully open. If you don't already have that value, you can create it as a rotator. So create a new variable and then select rotator from this dropdown. So we're going to take this in here and get that value. We'll delete the closed door rotation from here. And we're going to want to multiply this by the percentage that the door is open, the door opening value. So I'm going to bring out that pin and do multiply here. So I'm going to take this open door rotation and multiply it by the door opening value there. So multiply, and let's do scale rotator. And so let's multiply the open door rotation by the door opening value here, and then take the output pin and plug that into rotation. So now whatever value the door animation is at is going to directly affect the rotation of the door on every frame. So we need to connect the update to the set relative rotation. And now another thing we're going to need to do is that when it is making these update calls, we either need to set whether it is opening or closing. And the way that we can do that is using this direction pin. So we can pull out this direction pin and check if it's equal to its enumerable value of forward. So if it's forward, it's going to be opening. And if it's not forward, it's backwards. So it's one of those two. So forwards is opening, backwards is closing. And we can use a branch in order to set the values. So let's pull that over here, and we will create a branch node and have that set after set relative rotation. So the thing we're going to want to set is the state value. So what we can do is drag the variable over here and do set state. So if it is true that the direction of the graph is forwards, we're going to want to make it opening, and then we can put this execution, set it to opening, and then we want to do the false in the reverse direction. So if it is going the opposite direction, then it is closing. And this should be all that we need for the update execution. We could make a comment here, so I will select everything and say update the rotation on the door while the graph is while the timeline is moving, and determine whether the door is opening or closing. And that should be good. So next, when it's finished in this door timeline, it's either going to be closed or it's going to be open. So we're just going to need to determine that. And a good way to do that is to check what its last state was and then set a new state based off of that. So if we take the state and we get the state with a switch, then we can have finished come in here, and if the state was set to closing, then it should be closed after that. And if the state was opening, then it should now be open since the timeline animation is finished. So we can set the state again by pulling it onto the event graph. So closing goes in here and the new state becomes closed. And then we pull it out one more time to do opening to set the state to be open. And since we're properly updating this door state here, this means that whenever the player comes, interacts with the door, and it checks the state of the door, it'll be able to update the animation properly based on its current state. And we could create a comment, finish closing or opening the door by updating the state variable. Okay, so now that everything's linked up, let's go ahead and play the game and make sure that everything is working. So watch how on the event graph, based on how the value for the state is set, it's going to be triggering different things to happen for the door animation. So first off, I press F, it's already closed, so it opens, update runs for about a second. After 1 second occurs, it's in its finished state, so it goes and sets to open. So if I press F from its open state, you can see how it feeds into the event graph. It goes to reverse from end, making the door close rather than open. And what's really great is that because we added in closing and opening states, we can actually hit F multiple times, and we can reverse the direction of the animation at any point, even if it is currently opening or closing. And it's going to look smooth and play back properly, no matter at what point I actually interact with the door. Now, if you wanted to make it so that once the door starts opening or closing that you can't reverse the directions, then you could just eliminate the pins for closing and opening. So it doesn't actually do anything unless it's in its closed or open state. But if you wanted that extra step where you can stop closing the door and make it go back to open, then this should be perfect for you. And so I hope that this tutorial has given you a good idea of how to use the timeline nodes to do basic animation on your game objects. So I've been Chris, thanks for watching, and I will see you guys in my future Unreal 4 content.